Here's another example of inheritance, and I'll try to make this video a little bit shorter. Again, I'm trying to make things very simple here. This is a class which I named food, and it just has one instance variable called dessert. This is the constructor for food. Obviously, I'm just setting this instance variable, and then I have a toString here. So dessert is Boolean. It's either going to be true or false, and the toString method initializes this local variable des to nothing, and then if it's not dessert, so in other words, if dessert is false, des gets set to not. So the toString method is going to return I am food, I am either dessert, or I am not dessert. It'll get set to not if it's not a dessert item. I don't know, or it'll just say dessert if it is a dessert item. Anyway, let's look at a subclass of food called pasta. So this is it. This is pasta. Public class pasta extends food. Again, the keyword extends means that pasta is a subclass of food. Pasta is a food. If you can use the is a keywords or is, that sort of describes a subclass relationship. The subclass is a superclass. Pasta is food. Ice cream is food. It doesn't go the other way around. You can't say food is pasta. Not necessarily. All right. So here I'm calling the superclass constructor, and I'm passing it false because I suppose we're considering pasta not to be dessert. Well, I guess you could have it for dessert. Anyway, this is pasta, very simple class right here. And maybe I haven't talked about this before, but the pasta has, or a subclass has, all of the methods and variables in the superclass. It's kind of like when you look at pasta, you assume that toString is actually there. You can use the toString method because it's in the superclass. It inherits those. The only methods that are not inherited in a subclass are the constructors. So you have to rewrite the constructors in the subclass. But all other methods are inherited. All right, let's take a look at ice cream. Here's ice cream over here. Ice cream extends food. It's also a subclass of food. I added another instance variable called flavor. This is the constructor for ice cream. It's a zero argument constructor. There's nothing in the parentheses. I'm calling the superclass, and I'm setting the flavor to vanilla. This is a default constructor. In other words, if you run a constructor with no input parameters, the flavor will be set to vanilla by default. Here's a second constructor. This is called a one argument constructor. Again, I'm calling the superclass. By the way, the superclass, I'm sure I've said this before, but you must call the superclass constructor as the first line in the subclass constructor. If I switch the order of these, flavor equals F, super true, it would give me an error. So you must call superclass as the first line in your constructor. And again, so I'm setting the flavor to F. And you know that you can have more than one version of methods with the same name. These are both called ice cream, but they're different versions. The signatures are different. The list of parameters are different. This is called method overloading, by the way. And you don't have to do it just with constructors. You can have many methods with the same name as long as they have different parameter types, different signatures is what it's called. Again, it's called method overloading. Here I have a method that it's a setter method. I'm setting flavor to whatever the input parameter is. Presumably I could change the flavor to chocolate or strawberry or something. And then I have a getter method, get flavor. Set flavor, get flavor. All right, not a big deal. So I want to go through the tester method and talk about what you can do and what you can't do. And this can be a little bit confusing. So we're just going to go right down the line here, and I'll uncomment things, and we'll recompile this, and we'll see what's allowed and what's not allowed. So the first thing I have, and actually maybe I'll open up food again and put it underneath. So the first thing I have is I'm declaring a food, and I'm setting it to false, and then I'm going to system.println f. This is going to run the toString method, of course, in food, and this should work fine. If I run this thing, it says I am food, I am not dessert. That works fine. It ran the toString method in food. No issues at all. So we're just going to go right down the line and try one thing at a time. So here I'm declaring pasta. Pasta p equals new pasta. And if I run the toString method, system.out.println p, if you just say the name of the object in a print statement, it runs the toString method by default. So let's run that. This works fine. I am food. I am not dessert. How did it know pasta was not dessert? Well, when you create pasta, where's pasta? Right. When you create pasta, remember it calls the superclass and passes false to it. And again, it's running the toString. This right here is running the toString method in the superclass food. What's actually happening is it's looking for the toString method in pasta, but since it can't find it, it goes up the inheritance chain. Found it in food, so it runs that one. All right, no problem there. I don't think that's too confusing. This is also going to run fine. The next one, I create ice cream I is new ice cream. I run the toString method, and we can just run this guy, and you can see that it's not a big deal here. I am food, I am dessert, my flavor is vanilla. Why did it say my flavor is vanilla? Because I ran the get flavor method. Remember, ice cream has a get flavor method, so I'm running that as well. Okay, so this is pretty straightforward. Hopefully that all makes sense. The next bunch of things seem a little strange, and you might be thinking, why would you ever want to do that? There are reasons why this does happen sometimes, but for right now, I just want to talk about what's allowed and what's not allowed. So here I'm saying I'm declaring a food P2 is new pasta. The rules are this kind of thing is permitted as long as the new item is one of these. So in other words, pasta is food. So you can have superclass, something or other, subclass. That is permitted. Here above it, I'm just saying ice cream is new ice cream, pasta is new pasta. That's fine, very straightforward. But this is also permitted. You're allowed to say superclass something, new subclass. And this should work fine. And if I run this, so I have pasta P2 equals new, food P2 equals new pasta. If I run the toString, it knows that P2 is pasta, and it'll run it correctly. Everybody will be happy. So it says I am food, I am not dessert. Of course, it knew that because it's a pasta item, which is not a dessert item. So that worked totally fine. All right, I'm losing my train of thought here. Okay, let's go to the next item. Okay, this line of code is permitted. Food I2 equals new ice cream. This is allowed as long as this thing is one of these things. So ice cream is food. This is allowed. Food I2 equals new ice cream. No problem with that. And when I run the print line statement, it'll look for the toString method in ice cream. And if it can't find it, it goes up the chain, runs in food. No problem at all here. This line will cause a problem, and I'll compile this guy, and you can see what the issue is. It says, cannot find symbol method get flavor. So this is one of those important things. You'll see this sometimes on multiple choice questions on the exam. The issue here is that at compile time, when you hit the compile button, at that moment, it thinks that I2 is a food item. It thinks I2 is food. So as it's compiling, it says, wait a minute, get flavor is not a method in I2. Get flavor is a method, get flavor is not a method in food. Get flavor is a method only in ice cream. Remember, ice cream, you can get the flavor. Food, there is no get flavor method. So this will not get past the compiler unless you explicitly say, wait a minute, I2 is in fact ice cream, and cast it as such. So I'm going to do this funny casting thing here. I'm going to say, and notice I have two sets of parentheses. Oops, ice. You have to tell a compiler, yes, I2 is in fact ice cream, and ice cream does have a get flavor method. So this will work fine. And if I compile it, it's fine, and now everything will run fine. So yeah, my flavor is vanilla, right, I'm dessert. So let me just say this again. The reason this did not get past the compiler is because you were trying to run a method, in this case, get flavor, you were trying to run a method that did not exist in food. It exists in ice cream, but it did not exist in food. But when it comes to runtime, it knows to run the correct method. So when you run it, it actually knows that I2 is ice cream and will run the method in the ice cream class. All right, hopefully that makes some sense. One of those confusing things. All right, let's take a look at a few other things. Oh, am I allowed to do this? Pasta C equals new ice cream. Is this permitted? I hope you're thinking whether it's permitted or not. It is not permitted. Remember, the rules are this thing has got to be one of these things. So can I say ice cream is pasta? No, I can't say that. That doesn't make sense. So this would not be permitted. Let's try the next one. Can I say pasta D equals new food? Also not permitted because food is not necessarily pasta. You can go the other way around. But remember, in order to do this, this thing has got to be one of these things. It's got to be a superclass subclass relationship. Am I allowed to say this? Ice cream E equals new food. Also not permitted because food is not necessarily ice cream. All right. Let's take a look at the next couple of items. Okay. Food F3 equals new food. This is okay, of course. But is the next line okay? Am I allowed to then cast F3 to ice cream and run the get flavor method? I hope you're thinking about it. It actually gets past the compiler, but then when I go to run this, you'll see I'll get an error here. And the error is class cast exception. Food cannot be cast to ice cream, and hopefully that makes sense. You can't. F3 is not ice cream. I cannot cast it down to something which it is not. And in the other example up here where I did cast it, I2 was actually ice cream. You can't cast something down below something that it is not. So this is no good at all. We had a runtime error. All right, let's do a couple more. Almost done here. I'm trying to make this video quick, but this is complicated stuff. All right. Oops. I hit compile too quickly. So pasta P3 is new pasta. That's permitted. But here again, I'm trying to cast P3 to ice cream, which it is not. These are incompatible types. I can't cast something to something that it's not. Great. And the last example, let me space up here. The last example, everything is a subclass of this superclass in Java called the object class. So this is permitted. I'm allowed to say food is an object. Object OB equals new food. That's fine. And actually, this should be fine too. I'm allowed to run the toString method, and at runtime it actually knows that OB is food and will run the correct toString method. So just to be clear again, you're allowed to do superclass, new subclass, and when it comes to runtime, Java actually knows to run the method in the correct class. So it'll run the method in food. It knows to do that, and if I run this, you can see that that works fine. I am food, I am not a dessert. So pretty quick. Hopefully this makes some sense. And all right, you gotta see several examples of inheritance to really get it, I think. All right, go for it.